Hey, hello everyone. Welcome to Avient Specialty Inks. Today we're going to cover Screen Printing 101 textiles. And the reason we're doing this is because we've seen a lot of questions on the Facebook group pages asking some really basic questions, especially when folks that are already into getting orders and ordering screens, and then they ask a very basic question. First of all, we're just going to go over the very basics. This isn't for the professors out there and the gurus, but I'm glad they're on to chime in. And we want to reiterate, and I'll probably say it more than once during this broadcast, is if you're using a specific product, go to that manufacturer and ask them how it should be used instead of putting a question out there on.
So if you don't know this dude with the beard, this is the guru Ray Smith from Avient Specialty Inks. We've got John McGee, guru number 2, and me coming in last but least, Dan Solomon.
Yeah, right. So I'm gonna just go over the basics, and then Dan will mention, we'll chime in with some of the best practices, and then John will also chime in some best practices, but then we asked him to kind of play devil's advocate on some things when things we hear that people are trying to do and what can cause that problem.
It comes easy to John.
Yeah. So Screen Printing 101. So we're going to go over some. Hey, it's working now. Artwork, screens, ink, production, and cure. And this is mainly just the applications, how we go through to make an order. We can cover everything post production at another time.
Yeah.
So let's start with art creation. From day one, the art was created 3 basic ways. Not day, but since computers been around. Hand-drawn artwork, where you actually make a photo of it or you scan it, and then you create color around that, either by amber lith or ruby lith, or you're coloring it in on a vellum. Secondly is computer generated. And then third would be photographic, where you're using a high resolution photo of a piece of art or something like that, and bring it into Photoshop or some other program to create a really nice replication of a piece of art.
Right. So hand drawn, you're going to get exactly what you have drawn on your screen. With the computer generated, it's easy to go in and make tweaks when you see something that you don't like. And then the photographic representation, you really need to make sure you have a 300 DPI or better photo to be able to shoot it right.
And what we're showing here in this picture here is taking a drawing, a tracing, scanning it into Illustrator or Corel, and then vectorizing that. So tracing again with more detail in Illustrator. One of the key things you want to remember to do is any text that you add to your digital file to outline that. Probably the biggest gripe is getting files from customers where they added the crazy font and they didn't outline it, and you don't have the font in your library.
That's correct. I think I got one from you the other day.
Don't forget your registration marks. They're important on multicolor art.
Oh yeah. So let's talk about computer. This is probably the most used in our industry right now, is computer generated and computer separated graphics. And right here I'm showing a Photoshop file on the left and a Illustrator file on the right. Photoshop is real primarily for raster images, halftones for you folks out there. And then the vector is more clean line type of vector prints out of the Illustrator, and Corel Draw.
Spot color.
Yes.
Is what it is referred to sometimes.
Yeah, if you're new to this, just creating your own art is new. Jump into Illustrator or Corel Draw. Learn to design in vector, so that whatever you design, small or big, can be sized to whatever size that you need. You can edit it a lot easier. You can add your text to it. And then as you're making your separations, since you're building structural images, it's easy to grab those colors and separate those out into layers that will be your different color channels when you separate later.
And as you learn Photoshop, you'll find there's ways to put some smart objects in there and create some nice, clean images. So, but that's up for another time. So the goal, no matter what program you're using or how you're doing it, is to create an individual file for for each color. So we're going to make screens. We need one color goes to each screen. In this case, this is a 4-color process image. And as you can see, we've got the yellow, magenta, cyan, and black separated into a black image, a positive image. So where you want the ink is where you want the black, and then white in the background. So when you output it, say on a film, a clear film, you'll only see the black image on a clear film, and you want that clear film to be 100% free of any kind of image.
So in this process type printing, if you're not familiar with it, we're really blending those 4 colors to make that spectrum of color. And if you want a easy way to look at it, take a magnifying glass and look at a magazine photo up close, and you will see those cyan, magenta, yellow, and black dots.
Yeah, you really want to focus on how finely the detail is on those dots and how opaque they are. Your detail is going to be determined by how opaque it is and what that dot spread is. If you're printing on like a vellum, you're going to get some light scatter and you're going to get ink scatter, so you're not going to get real tight lines on those edges. Your definition is really important right here, and I think Dan, you mentioned earlier about 300 DPI is what we want to start with.
Exactly. So the different output devices you'll use. Here's one, that can be printed onto film or vellum. That's probably the most commonly used is this type of output, like an inkjet. And what John had mentioned a while ago, your dots aren't going to be perfect. They're going to be a little spread, especially on the vellum because there's a surface. You also have
that printer, Ray, that you were just looking at has the 4 colors, CMYK, but there are all black ink kits that you can get that'll save you some money.
Yeah, and also that's all you need for output in film is.
Yeah.
The only reason you would have the other one is if you're doing some kind of comp for somebody.
And this one is converted to all black. So all 8 of those cartridges are all black ink. Now, when you're choosing your film, talk to your local screen print supplier. You want a water-resistant film that's not going to stick to your screens and lose detail when you pull it off. Again, if you're looking at vellum, you're probably going to have to look at a spray toner to make it more opaque. But again, vellum's going to have light scatter from light going through the film, which will make more sense later. And also just that little bit of ink, that edge definition is going to scatter a bit.
Again, ask your distributor or your vendor, because if you just put a question out there, what's the best to use to output films, you're going to get all sorts of different answers. And whether it be cheapest or best, you usually get what you pay for. So there's a reason why there's different types of mediums out there. So here's an output that's basically going to a computer file, and that's for a direct-to-screen. And this gives out really nice halftones because you're going directly on the screen instead of transferring over from one medium to another. And we'll look at these here in a minute. We'll see how they work with the output device. So let's talk about screens for a second. Screen frames. The most popular out there is a wooden static frame. Close behind it is a aluminum static frame. There's also static frames that use a tensioning table like a Sherlock or something like that gives a really nice look, and it holds tension very well. You guys all have experience with all of these frames, so I mean.
Yeah, I mean, you got to remember, this is screen printing. It's not called anything else but screen printing. We print with our screens, so they're very important. So if you get a screen that you can't control, you're not controlling your print parameters. If you have a screen with more control, a tighter screen, a screen that's going to pop off the print after the squeegee blade goes over it, you're going to get better prints and better definition. With a wood screen, using that in dip tanks, it's not very friendly to dip tanks. With the metal screens, they're a lot more friendly to dip tanks, to reclaim, to holding their tension. They're not susceptible to humidity changes, dryness changes. So I always want to start with a metal static frame, and in a perfect situation, a retentionable frame. I like to check my screen tension after every reclaim. Not
only that, you're getting this wood wet, and it tends to warp over time, and you start having some bad off contact when you're printing.
Yeah, so John's mentioned tension quite a few times in the last couple of seconds there, and he's mentioned it because it's critical. I mean, if we're not printing through something that's 18 to 35 Newton meters, then we're really trying to print through basically, right? And what we want is to be able to transfer cleanly that ink through a tensioned screen, a well-tensioned screen. And in this slide, you can see a Newton meter. And basically, it's just a small divot that comes down, or
Grab one.
point that comes down, and then measures how much tension is in that screen. But if you don't have that, I mean, it's not a cheap fix. Just start to get the feel for the sound of the screen, or a quarter on it. You need a good well-tensioned screen.
Well, and the best way to really control your tension is a retensionable frame. So, I mean, and most beginners don't use these. They're a little more expensive, but over time they pay off, especially if you're doing a lot of screen changeover. You'll find that the static frames will lose tension over time, and you just have to replace them. The retentionable screens will give you the opportunity to retension them after you reclaim them and start anew with a good tension screen.
So just a starting point, if you tap your screen and you don't get like a snare drum type pop back, it's too loose. If you hear like a dull thud, if it sounds floppy, you shouldn't really print anything more than a one color with it. You want a really tight screen to pop back off of that ink, because you got to think about your inks slicing through the screen filament like knives and slicing back up through it. If it's saggy, it's going to pull the ink up all uneven. You're going to those weird fibrillation and weird topography differences in your ink deposit.
We'll show off contact in a minute, and it's critical for that too.
But that's important too. As Ray said, that a lot of people that are small or starting aren't going to spend the money on a tensionable product, and so just inventorying your screens makes a big difference. So if you have some 110s that are really saggy, but you still want to use them, make sure you put them to one side and label them that you're only going to print that at one color.
Yes. So we get into the mesh, basic mesh. So the mesh count equals how many threads per inch that mesh holds.
And a low mesh count doesn't mean you can't hold detail. It means you have to have a good screen print or a exposure process to hold that detail. It just means more ink is going to pass through that, which could mean more dot gain.
And there's other threads out there. There's smart threads that are lower in diameter, and so they're thinner diameter thread. So for a 110 and a thin diameter mesh, you will be able to pass more ink through that screen, and that helps you with opacity, ink volume, thickness, if needed, if you want that desired effect.
Yeah, and so this is all about open space, so that's what it is. So less threads will have more open space. Thinner thread will be more open space. And you see here, we give an example. A good athletic print probably go through 110, and it's pretty common. And then for process printing and very high end detail printing, you'll use a 305. So it's 305 threads per square inch. So and it's usually a thinner thread too. So that's the idea behind the mesh. So we got different types of emulsions out there. Two of the most common used are a dual cure emulsion and a pure polymer emulsion. Whoever you're using, whatever emulsion company you use or distributor you use, they have them. So you just ask the company you buy from, can you have one or the other, and why? So that's
what the percent solids is in those, because that'll make a difference depending on the type of printing that you're doing.
I think the thing to pay attention to for new printers, your dual cure, you add a diazo powder to it, and you've got to let it sit overnight. Bubbles are going to rise through that. If you use that emulsion too soon, you're going to see those emulsions in your coating. With your pure polymer, it's ready to go out of the bucket. Also, as soon as if you have an exposure unit that's out in an open area, that's not in a darkroom area, as soon as you can take your exposed screens off the machine and put them into water, just a clear dip tank or spray them with water, your pure photopolymer will be stabilized. Diazo needs to stay in a darker area. Wash it out and develop it in a darker area where the pure polymer is a lot more forgiving.
And you would use that dual cure or diazo cure or even post curing for really for water-based inks, because the water is a solvent to these photopolymers. But for plastisol or silicone printing, the pure polymer is generally what you would use.
Well, here's a good example of manual coating. So you fill the tray to the top, your coating tray, and you lean that screen up against either a holder or you I many times use the wall, and sometimes I do it one-handed, holding the screen. And I just make sure you get a good, even coat. And the way I coat, I'll do one flood on the front, the shirt side, and then I'll do 2 coats on the ink side, pushing the emulsion back through the screen to make sure that emulsion is pushed out to the outside of the screen. That's where you want your stencil.
And we'll cover that in the stencil or the gasket section. But if you're not familiar with the terms that Ray just talked about, talk to your ink supplier about the best strategy or program to use. 1 + 2 is what Ray just described. A lot of times we'll do 2 + 2 or even 3 + 3 if we've got a white print going on a really red shirt. Then we want to develop more ink layer to block that ink color with the opacity that you're working with that ink system.
Yeah, and Ray mentioned coating with one hand. If you can avoid it, try not to coat with one hand, meaning holding the screen with one hand and your coater in the other hand, because you're moving two things together. Lean that screen up against the wall if you can get it about waist height. And just like in the photo here, use 2 hands to bring that up and control that speed and control your deposit going up. But on top of that, your coater, I see them thrown all around screen rooms. You don't want to nick the edge of that coater. You want it to be perfectly uniform and brand new as long as you can. That's what that little plastic cover is for. It's not to put wet emulsion in there and save it in there. It's just to save your edges of your emulsion coater so you don't get lines in your emulsion. And if your screen's too loose, you're going to get those thick deposits of emulsion and the running of emulsion. You want a tight screen to rebound against the edge of the coater.
And eventually, if you can afford it, that's a good way to go with automatic coating. And so it delivers a really consistent coat that once you zero in on what you like, you can just hit the program and let it go.
One of the things that we haven't talked about, but in specific, but we actually have in this discussion is all of the variables that go into screen printing. So once you go to an auto coater, you're going to take a lot of that variability out. Your screen tension is another one, but man, folks, write it down, document. The biggest thing, if you want to reproduce, if you have a customer that's going to come back and you want to reproduce that color, that print job, write it all down, and then all you got to do is flip to it and say, okay, this is what we need to start with.
And I'm going to jump back and add one last thing. Ray talked about the coating order, the point being that the last coat you're coating from the well side, the inside of the screen, to push all that emulsion down to the bottom. And you want to dry your screen face down so gravity pulls that emulsion to the bottom and gives you that profile that you want to bite into. You want like a cookie cutter type gasket, not a stencil. We're not stenciling, we're screen printing.
Yeah, so that's very important. I didn't have a photo of the drying rack ready this morning, but that's exactly right. Get a nice rack, face down, and let it dry. Let it dry for a while. And you want to put it in a room that's, hopefully elevated heat, like 80 degrees, and then the humidity is low. So you can use a dehumidifier in there to pull the water out of that.
Another variable to control, and this is a $3 humidity and temperature gauge. Put that in your screen room and just write that down in your notes, and you're going to notice differences in the seasons.
So here, I'm going to do a quick, synopsis of what we're doing here. So the idea is when you're coating that emulsion, the emulsion is light sensitive. So what it means is when you coat it, it does dry and you keep it in a dark room, it will not harden until you expose it to light. So what we're going to do now, we're going to coat it. We have the screen, we put the image on it, and where that image is, remember we said we did a positive, which is where you want the ink is where the black is on the positive. If that black protects the screen from the light, everywhere else is exposed to the light, it hardens, and then it leaves that image ready to wash out. So let's go right to that. So here's some folks, they use the film output. So this is probably most common used now still. It's not the fact it's, the other things are growing fast, but this is probably the most common, using the film. You're taping it on the screen, and then you expose that screen right to light.
Yeah, and you'll put that under, typically we'll put it under a vacuum table, which will make sure that there isn't any separation between the emulsion and your film, because you don't want light to crosshatch, because that's going to erode your edges, give you kind of a choppy look, as well as negatively impact that gasket that John was mentioning.
And that's just other reason why I know a lot of people say, hey, I expose in the sun. Well, yeah, I guess that could work, but you better have something against that piece of glass or something to keep it from moving and allowing that light to get down and around it. You know, you're outside, that light gets around behind the screen and makes it harder to wash out.
Well, also for registration issues. So if you're using like a tri-lock system, and you've got a pin lock on your glass of your exposure unit, and you're using a carrier sheet, tape the carrier sheet to the glass, and tape the bottom, the top and the bottom, because when you start to evacuate the air, that vacuum blanket's going to ripple that plastic just a little bit. And when your image looks like it's in registration on 3 corners, but not the 4th corner, that might be one of those things that went wrong. I mean, like Dan said, there's a million variables to control in this. The more you can control this and give it more process, the less you'll hate it.
And so then eventually, hopefully, you can save your money and get a direct-to-screen, which takes out those variables. You don't have to vacuum it down. It's directly printed onto the screen itself. There's no off contact. It's on the screen, and it's put in the exact same spot every time on your screen. So now your pre-registration works better. Everything works better with the direct-to-screen.
You don't have your film moving, and then you're not shooting for your film. Film shrinks your image just a little bit. I mean, if you want to choke another image, add another piece of film to it on your glass. But with taking the film out of here, you're getting better detail, faster exposure,
and better dots.
Better dots.
Yeah. So once you have the image on your screen, you're exposing it. Some people call it burning screens, maybe exposing screens. So you're exposing it to light. So here's one of the most common ones. You just have light source. It could be a small box. It could be a big enough. This is for starters. Starter kits usually have something like this in there. So you're exposing the light, exposing the emulsion with the light, and again, your film positive is protecting the emulsion from being hardened.
Now, can I mention the little difference between these exposure units?
Yeah.
So let's go back to the fluorescent tube real quick. On that tube, you've got light coming from all directions, and it's bouncing off the bottom. And if you've ever looked at a fluorescent tube, it's never even across the bulb, especially as it ages. So you've got lots of different angles of light going around your stencil, shrinking your stencil, and not getting that detail that you want. Whereas if we show our next exposure unit, the metal halide, this is your best detail. It's one single source of light shooting straight up at the film evenly, giving you better edge definition.
And I think a lot of the folks that you'll see that award winners with the halftones will agree with you on this particular case. This is not for high production. This is for better detail.
So the LED that Ray will go to next is really going to be all about speed. Really, we can expose that screen in less than 10 seconds versus a minute and a half or more.
Yes, but you got to watch it. You expose it too long, you have light getting inside your image area. But for most people, if you work with the emulsion manufacturers and with the machine manufacturers, they can give you a very good starting point. And what you want to do then is use an exposure calculator to make sure you're doing the right thing.
Yeah, because what John was saying about light bulbs and intensity, this is where using this exposure calculator on a regular basis is going to keep you controlling that variable of light. You're going to start to see over time in exposures a difference in the time that you need to expose that, or your image is going to wash out, or your emulsion is going to wash out. When you start to see that change, run this emulsion tool here, the exposure calculator, to make sure that you're dialed in, and then start changing bulbs.
And this is to the emulsion manufacturer. Ask the emulsion manufacturer about this and let them explain to you how to use it.
Now, per your exposure unit, for your fluorescent unit, you should use this calculator often. The bandwidth of light that fluorescent tubes put out usually isn't the right bandwidth to adhere your different layers of emulsion. So we talked about doing a 2-in-1 coating your screen, you want those layers to remain on the screen and not wash off. So you need the right kind of light to penetrate through that. So use this calculator often on a fluorescent unit, and then on your metal halide, use it every 3 months. Every 3 months, you should see a different, definite change in your light bulb aging, becoming weaker, and you'll need longer exposure times. With your LED, you do it once per mesh, and you should be good for the lifetime of that unit.
So obviously we have our screen now. It's been exposed. You can't even see the image on the screen, but once you put it in underwater, you see it drop out. So the ideal situation is to have exposed to a point where you can actually blast that image out. If you're having to work so hard, to get it, it means you probably overexposed or underexposed, and where it's washing out.
So Ray, we got a question on the line about that. If you want to take this call,
I can't talk.
You've got two different. You've got a high pressure washer system here, and sometimes you'll just wash it out with standard hose pressure. Do you have So that's really just about control, how you can control the distance, the pressure, speed, and making sure you're getting pinholes.
And once you have this dialed in, it's pretty quick. You can get through these screens pretty quick. So here.
But if you're
if
you're really working on it with the pressure washer, then your exposure time is not correct.
Yeah,
when your exposure times are correct, you should be able to wash it out with the regular standard hose pressure.
I usually a lot of times I'll use the pressure washers for speed, and I'll just back off, let the mist knock it out, and I'm done. It gets everything out. So then you're pre-checking the screen through with a light, and throwing tape around the edges where your scoop coated in hit, and basically you are ready for press.
Let's go back to that last picture real quick. So I built this up real quick with just like a U-line tape dispenser and a fluorescent light from Home Depot. The point was we went from regular Plastisol printing to more water-based and discharge. On Plastisol, if you get a little pinhole or dot, you shoot it out with your spot gun. But with discharge or water-based, you can't shoot it out. Yeah. So this became really important to find every little pinhole so it didn't surprise us later, even in any weak spot that would become a pinhole later.
We got to keep moving here because it's 27 minutes already. I know
that is a really good picture of a stencil, though. I mean, that's going to be
a great looking picture.
Really zero in.
EOM, which we would call EOM is emulsion over mesh. It's that gasket that you have, and that's a really good description.
Yeah, and all inks needs a good gasket. So we're picking our ink out now, right? So we're ink manufacturer. We're not going to spend very much time on this. If you have any questions about inks, call us. We'll help you out. But very first thing when you talk about ink is to know what you're printing on. So, here's a picture of a cotton shirt, a blend, and 100% polyester. So they're all going to need different types of ink. Obviously, the polyester is going to need a bleed resistance. The blends can use a general purpose, which has a little bit of bleed resistance in it. But mainly, you got to know what you're dealing with first and call the ink manufacturer at that point if you have any questions. And then, of course, there's other inks. Obviously, there's a Plastisol, non-PVC Plastisol. There's water-based. There's silicone. And then in water-based, you have discharge and high solids and, the regular everyday soft base. So there's so many different types of inks out there that make
pure inks in that too, for some of your bad dye migrators and polyesters.
Yeah. So if you have any questions on those, you can actually go back in our Facebook Live events. We talked about all these things. So let's get into production real quick. So in the production area, obviously the first thing you want to do is kind of set up your machine. Here we have John, I think, the younger John.
Yeah, much younger.
putting paper on his palette. I mean, that's something it's good to have palette tape just because it's easier to clean up in between jobs. If you have all the time in the world, I guess you just clean off your palette, but it protects the palette from lots of things like heat and so on. And then you're putting each screen into the machine and you're lining up those images between all the colors. And there's the old manual ways. Obviously, you print your key line or the part of the design that has the most image in it, and then you line up your other colors to it by eye. with the newer Trilux and pre-registration systems from other companies, it makes it much easier. My only advice is to embrace those if you have it. Use them because
So while we're looking at the setup, what we're going to do is we're going to make sure that we have a off contact to the palette of the screen, typically about 2 to 3 millimeters. And what we want to do with that is on our flood stroke, we're filling that gasket area. And then on our print stroke, I don't really like the term print because we're really transferring that ink. And if we're driving it into the fabric, then we're losing opacity, we're making it stiffer. We really want to just be able to transfer that with a good off contact, which will pick up the screen as your squeegee runs off it. And then we usually do what's called a peel, where we'll make the back of the screen, depending on your direction of travel, lower than the front.
Right.
No.
That'd be an automatic.
Yeah.
So was that where the squeegee's going away from? You want that a little higher. Yeah. So it peels away as it prints.
Yeah. So I think about the bottom of the squeegee kind of coming down a lot. Like if this is the surface of the mesh is coming down with the squeegee to the shirt while the frame is still hovering above a little bit.
Yeah, and very, very important. Manually, you want to, if you watch an automatic, it floods while its screen is off contact, way off, and then it goes down and prints. Same thing with manual. Flood while it's up because it's much easier to flood. There's no resistance to the ink going through the mesh. You're actually taking the ink through the mesh into that stencil area, putting it down and printing very lightly. The more ink you can get through that stencil, the less pressure you need to print.
Yeah, so our friend Steve Lowry was always critical of me because when I first started printing on the manual with him, I'd never hold that screen up. And he'd really want to slap me, but he was pretty good. But
so a couple tips real quick. Going back to registration, we talked about that real quick. If you don't already know how to do a tape-up registration, call us, ask us how to do it, talk to your local distributor. But basically, if you find yourself going through a lot of T-shirts, a lot of Pellons, a tape-up registration is putting on one Pellon or one shirt, printing your underbase, and then putting packing tape all over that, shingle taping it down so it overlaps. Then print your next color, check it for registration, then dry wipe it. You don't need any chemical. Just dry wipe it off of it, make your adjustments, and then check again. And just use that one shirt for that one print. The next thing I was going to add, I already forgot. What was the next picture? We were talking about off contact. I don't remember. It'll come back.
Yeah. Well, it's mainly flash gelling. So this is if you're going multicolor, you want to flash gel that ink on the shirt before you go to the next color. And this is primarily used for white flash and colors on top of white. But some people seem to like to use it between color if their artwork's not pristine. It kind of helps clean up edges and things like that. One thing I recommend is just don't overuse it. If you can get your artwork fixed and everything else fixed, your registration fixed, and use less flashing, you're much better off. Your machine lasts longer. Your ink cures better. Everything's better. And then you're able to use a lot of wet-on-wet multicolors after the flash more consistently. You end up with much nicer prints.
Now, if you've ever seen a print where it looks like the top colors have flaked off, they overflash the underbase. So they turn the underbase into a piece of plastic the top ink wasn't successful in biting into. So think of your underbase and your top coat as a primer and a top coat on a car or whatever else you're printing. You want that underbase to be soft, like Ray said, pudding skin type gel. If you can push your fingernail into it and leave an incision there, that's good. But you want it to be able to receive the ink on top of it and then that inner coat adhesion to occur. If you've overcured the underbase, it won't.
And remember, while you're printing, you put that, usually the ink going directly to the garment, it's going to take a little more pressure. It's like 45 or 50 pounds of pressure. But when you're printing on top of a white or on top of another color, it takes very little pressure because now you're not printing on a T-shirt anymore. You're printing on a piece of plastic. So you use very little pressure. You get much more opacity and much cleaner look.
Try pushing your squeegee. So like Ray and Dan were saying before, when you're flooding, you bring down your screen, hold it about halfway, flood with decent medium pressure, put down the screen, and then push just to shear off the top of that ink. So think of your stencil as a cookie cutter that you fill with ink, and then you shear off the top.
Basically, you're cleaning the screen surface. That's all you want to do. So obviously, we load the substrate. This is very important. Actually, people have problems with this. You have to learn how to get this loaded straight. you can buy a cheap laser to attach to your manual, or you can get, a lot of times the machines have the lasers to kind of help you line up location wise. Then the print parameters. So we talked earlier, flooding, putting it down, you're printing and you're allowing it to peel off. If that screen is sticking to your shirt, when you pick it up, it's going to create a modeling look. So either you have a loose screen or you have not enough off contact. Either way, if you're using a loose screen, you probably need more off contact to get the peel away. On an automatic, a lot of times we'll slow down or we'll speed up our flood and stroke and give it time to kind of peel away before the machine lifts. Manually, you have to do the same thing.
And folks, in a manual, the QC starts right here. You're looking at our friend Jim Sue. He's already checked that artwork before he's going to offload it, because if he has to come through and give it another hit, he still can before he removes it.
So obviously, next step, after you print it down an oven to cure it. So this is probably the most important piece of equipment in your shop, because up until now, you're doing all these great things, but it doesn't matter if the ink doesn't stick to the shirt, does it? If you throw it in the wash and it comes out or cracks, it's no good. So,
well, on top of that, let's go back real quick. Another failure that can occur is your ghosting or sublimating, from allowing shirts to just pile up in a box. The reason these tables are designed this way are, one, so that 4 people can gather shirts off it, but mainly so that when you have polys that are unstable, you start with shirt 1, 2, 3, 4, 5, 6. Shirt 7 goes on top of shirt 1, giving it time to cool down. The sooner you get your shirt down to room temperature, the more stable that shirt is. I take a call about this pretty much every single day that breaks down to somebody's hot stacking or allowing shirts to gather up in a hot box where that ink, where the dye in the shirt's unstable and the ink's receptive to receiving that ink or that dye. So the point here on this table is be able to make multiple stacks, then make your stack of 12, push it across the table to the next person who's putting it into the box.
So in the heat chamber on an oven, I have an example here of a gas reading and a electric reading setting. So it's not about the settings; it's about what temperature you reach in the oven. So in this gas setting, 325, the speed it takes for it to go through this oven and hit the temperatures recommended by the manufacturer. If you don't know what the recommended temperature is, call the ink manufacturer. Find out and make sure you're hitting it in the oven. So the settings may vary, So if someone says you got to hit 320 and you set an electric dryer on 320, you'll never hit it. It's just not going to do it. It's a surface reading.
Get yourself a heat probe, check.
There we go. And so the very best way to see what's happening to your ink in the oven is to use the donut probe, or it's called an Atkins thermal probe. You put that crosshair right in a wet ink on a scrap piece of material on the ink you're using. And as it goes through, you can actually see the temperature rising. It's a slow rise. And our old friend Rob Coleman used to say it's like cooking a turkey. It's like the fatter it is, the longer it takes to raise. It's not going to hit that temperature right away. It's going to slowly build. And as it gets to the end of the oven, it may hit that temperature for 7 or 8 seconds. For Plastisol, that's great. It's going to do it. On other inks, it's real vital to have some time in there. So if you're going to a shorter oven, which we'll cover in a second, you got to make sure you're going slow enough for that temperature to rise. Once you have that setting, then you can use this gun to kind of give you a reference.
Right, it's an IR gun.
As they're coming out, you can hit it at a certain spot and say your surface temperature is, X. But knowing that you did the thermal probe, you know what that temperature reading should be. If it ever varies from that, run your thermal probe again. And then
the infrared guns aren't as accurate as the probe for sure. But there's also some tapes that you can use.
There's a tape on there too. And so on these tapes, you're really not going to get the good reading unless you print right on top of the tape, or you put the tape on the underside of the shirt, and usually you're getting too hot. So I recommend, at least borrowing a thermal probe at one point or another and get a reference with the thermal gun.
I know we're going long, but this is one of the most important things that I see on the forums and in questions. I see people asking, what temperature does my ink need to get to? They say, just get it to 320 and you're good. I see that over and over again, and that's not true. We need to gradually climb up to that temperature, hold that temperature for 6 to 8 seconds, and then cool down as quickly as possible so we don't have any dye sublimation on our blend shirts. But those temperature strips only tell you, if you use them correctly, what the max temperature was. The infrared gun only tells you what the reflected temperature was, not the temperature of the ink. So if it's a white ink deposit, it's going to show a reflected heat level higher than what black's going to show, because black's going to absorb that laser beam more than the white's going to reflect it back. Your Atkins temperature probe costs $300 to $400. That's one ruined batch of a small batch of hoodies ruined. So you can save yourself on that one. I go everywhere with a temperature probe. Ask anybody. I've always got one on me.
So we have this versus the long dryer versus the small electric dryer. There's quite a difference. Again, we're just reiterating, there's no one better than the other. Just one's faster than the other. The longer the can, the faster you can run it, because that temperature is going to hold that garment in that space for X amount of seconds, and it gives it the ability to rise and hit that temperature. On a smaller one, you have to use that thermal probe and find out where you have to run it. A lot of times it's very, very slow, and to hit that temperature. And you don't want, whatever you do, you don't want to be broiling it. So you don't want to set on 1200 and try to run it fast. It doesn't work. You got to
look, folks, we're really tailoring this to this audience. This is Screen Print 101. We're showing you everything that's out there because we really want you to know about the options as your business starts to grow. What upgrades are the most important? And again, you can go to a bunch of webinars, seminars, ask industry pros, get on some forums, and figure out what's the best bang for your buck as you start to grow.
And somebody just asked what's the most accurate. The Atkins thermal probe is the most accurate. You know where it was hot, where it was cool. You should do both sides of your dryer, just like your gas grill at home. There's a hot side and a cool side. You should preload your belt with shirts that are going to evaporate humidity and cool down the chamber before you do your test shirt. So make everything as close to production environment as possible. Does that make sense? Production scenario.
So here's what happens.
Hold moisture in a more humid environment.
One more time, Dan.
Cotton will hold a lot more moisture in a humid environment than a polyester will. So you'll have to, go slower with that cotton to evaporate the moisture and then get the ink to cure to the right temperature.
Yeah, if you live in Florida, you probably run shirts through a dryer before you print them if you have a small enough shop.
So here's a good example of things that can happen if you're not curing. So, you get cracking, you can get long-term wash problems, and you get long-term dye migration. So that's something you need to watch for when you're curing. This is, like I said, it's the most important piece of the puzzle, as you're going through. Excuse me. A lot of people ask, can I cure with a flash unit? Well, it is possible. Excuse me. But again, you're doing the same thing. You got to see what the amount of temperature and time it takes for you to reach that cure. And it's a lot of time it's just a surface temperature. So you need to have a probe inside the ink and see where it's reaching.
Yeah, you risk curing the top layer of that ink and then just locking in the soft layer like a soft chewy, chewy. I can't say chewy center like a candy
gooey
bar, but gooey, yeah. But you don't want to seal it up. It'll seem cured. You can stretch it. It may not crack. But once you wash it, water gets to it from the underside and it hits that soft ink, then it starts falling off the shirt.
And what John said at the beginning of this is when you start to have to reprint because you're having adhesion issues, migration issues, because of your cure, all the time that you got to take those shirts back, you got to buy new, you got to put new ink on, you got to reset up the press. Sure that you get this last, very important.
We're losing you a little bit, Dan. But so I'm going to jump in other negatives about using a heat press. It's going to make it glossy. If you use the Teflon sheet, your ink surface is going to look more glossy. If you use parchment paper, you can get more of a matte finish to it. Again, with using your flash, you've got no reference point other than counting Mississippis in your head to how long that's been under the flash dryer and how undercured or overcured it is. How do you check that as you go? Again, these, if you're curing with a flash dryer or a heat press, this is just where you are until you move up to a dryer.
Yeah, and like I said, this is probably one of the most important pieces of equipment in your shop. It's worth the money to invest in that. And really, they're not that expensive. If you get a good long, you get like a 6 or 8 foot dryer. It helps you over those 4 foot and 2 foot and the flash units. That's probably one of the first purchases I would make going into if I open a shop.
But just don't trust the readout. If it says 450, it's not getting 450 because the probe that's reading that is either in the infrared panel or near the quartz bulbs and not near the shirt or in the shirt where the ink actually is.
Well, guys, I think we're at 45 minutes. We probably need to close up, but I hope we answered most of your questions. We can cover more things. Send us email. Hey, throw comments down on this broadcast. We'll be on it to answer any questions. It's really been fun. I love doing this basic textile. It's my elevator pitch to people out there that don't know what I do. And when I explained the whole thing, I said, well, what part do you do? I said, well, that little part in the middle where I make ink, so I hope that.
Yeah. But, it would be surprising to a lot of you, too, how many of these mistakes that we see in bigger shops we have to correct, too. So, look, we always want to reference what we have done, but we're always moving forward. We're not looking back.
All right, guys. Thank you for joining. Thank you, John. Thank you, Dan. And I hope we can answer more questions later. You guys keep posting. Appreciate it.
See you guys.